Today we're talking about lesson 2.4, which is complex numbers and operations. This is new at Algebra 2. Okay, this is not something that was introduced in Algebra 1. Definitely new to Algebra 2. Now, I will say that was back when you guys had Algebra 1. It is actually in the Algebra 1 standards now instead of the Algebra 2. But that's, I still have to introduce it here. Okay, let's go with the basics here. Square root of 25.
5.
5. And why is it 5? 5 times 5 is 25, right?
Yes.
And keep in mind, we all do, when we have a radical sign, we do only want the positive solution there. Okay. What is the square root of negative 25? Okay. Okay. So, because if we say 5 times 5, that's positive 25, right? What's negative 5 times negative 5?
25.
Also positive 25. So do we have, for square root of negative 25, it needs to be a number times itself. Do we have a number times itself that gives me negative 25?
No.
No, we don't. So at this point, okay, it's an error on the calculator, right? Okay. Up until this point in your lives, we have said that there are no real solutions, correct? The calculator gives you an error. We just say we can't do it. No real solutions. Until today.
Oh,
Okay? Today, we are learning about complex numbers. And complex numbers involve something called the imaginary unit. Okay? We're learning about imaginary numbers today. Up till now, all of what you've done in your math career is involved with real numbers. Whether it be positives, negatives, whole numbers, fractions, decimals, it's all been real numbers. But there is also something called the imaginary numbers, okay? And they're part of this complex number. So a complex number uses what is called the imaginary unit. It is we use I to refer to it. So for that reason, you don't usually see me use a variable of I, because I is the imaginary unit. Now, it does come up sometimes, and I is equivalent to the square root of negative 1. Normally when I say what's the square root of negative 1, when you ask your calculator what's the square root of negative 1, it's not a real number, but it's I, which is the imaginary unit. Okay? So that's what we're going to be working with today, is we're actually going to be taking square roots of negative numbers. So everything we're working with today is, okay, how do we work with imaginaries? Two basic ideas you need to be familiar with. And those are the fact that I is equal to the square root of negative 1. Okay, that is the value of I. And when you square I, you get the number negative 1. Okay, so if I take I and square it, well, what happens when you square a square root? When we square the square root of negative 1, we get negative 1. So those are the two big pieces of information you have to walk out of here knowing today. Square root of negative 1 is I, and thus I squared is negative 1. From this idea, we can square root negative numbers. Okay, and we can solve equations that previously we might not have been able to solve. So, square root of negative 9. I should have made this one square root of negative 25 so we could go back to that problem, but square root of negative 9. What do you see here? You see the square root of 9, yes?
3.
And our brains say 3, and there's a negative there. And that negative is going to say, okay, instead of just saying 3, we are going to say 3i. Now, to think about it, to break it into pieces, I think of it as this way. Negative 9 is negative 1 times 9, correct? And this is for, some of you are going to need to visual. Some of you are seeing it, you're like, got it, 3i, I understand. Some of you are saying, what? So let me make sure I get all of you guys out there too. Negative 1 times 9 is negative 9, yes. What did we just say the square root of negative 1 is? We said that was I. What do you already know the square root of 9 is? 3. And then, logically speaking, I is not a variable in this instance, but we're going to treat it like 1 in everything we do. What is I times 3 best written? 3i. Okay? So, if I bounce back up here, what would be the square root of negative 25? Since if we talk imaginaries, we could call it 5i. Okay? What about something like b? Square root of negative 7. Do you know the square root of 7 off the top of your head? Should you know the square root of 7 off the top of your head? No, because 7 is not a perfect square, is it? So in that case, we're going to leave 7 as is. I'm not going for decimal answers today. Okay? But what about that negative? In other words, if I break this one down like I did the previous one, and what do we know about negative 7? Negative 7 is negative 1 times 7, correct? What did we just say the square root of negative 1 is? I. What's the square root of 7? Well, for our current purposes, I'm leaving it as the square root of 7. Unless it's a perfect square, or there's a perfect square in it, I'm leaving it today. What is I times the square root of 7? And I'm going to write it as I square root of 7. Okay? Now, could you say square root of 7 times I and put the I out back? You can, but you have to be very careful about it because the I does not go underneath the square root sign. If I say radical sign, are you guys familiar with that word? Radical being a name for the square root sign. Okay? We want to make sure that that I is not underneath there. Typically, we tend to put something like an I or a variable out front. To be honest, I don't know what I don't know what Math Excel type homework wants you to do. I don't remember. Okay. That's the whole thing. If I'd gotten it assigned like I meant to do last night, I could answer that question better, but I forgot about it. Okay, C. I'm going to make your algebra 1 brains work on this one. Square root of negative 12. Well, what did we definitely see? We definitely see negative 1, yes? What about 12? Can we take the square root of 12? Not and get a whole number. However, if you leave it as just the square root of 12, I'm not going to be happy either. So you have to think back to Algebra 1, and you learned how to simplify radicals. And we have a chapter later on that we'll do a lot with simplifying radicals. But in the meantime, we're just going to review some of the basics. What do you remember, Aiden?
Square root of 3 times square root of what?
And why would we use 3 times 4? What's important there? Okay, 3 times 4 multiplies to be 12, and one of those numbers is a perfect square. In other words, if someone else said, oh, well, I was going to use 2 times 6, would I like 2 times 6 as well? No, because can I take the square root of 2? Can I take the square root of 6? No, so I don't like 2 times 6 in this case. But I like 4 times 3 because I can take the square root of 4. So numbers that aren't perfect squares. I'm not saying this is going to happen a ton today, but it does happen some. Look for perfect squares within it that we can simplify. Okay? What is the square root of negative 1? I. Good. What is the square root of 4? 2. What is the square root of 3? It's 1.7 something is what I know, but that's not what I want right now, is it? Square root of 3 is just going to be square root of 3 because it's not a perfect square. Okay? Best way to express this, well, how would you express I times 2? 2i, so I'm going to say 2i times the square root of 3. Okay? So when you see negatives, pull out that square root of -1 as an I. If you see perfect squares, factor those out. Okay. One last one in this section, D. Square root of -18. What's the obvious piece we all see? There's going to be an I. There's a -1. Okay, think ahead. What about 18? Can I take the square root of 18 as is? No, the square root of 18 is some decimal. Okay. Do I leave 18? Or do I break 18 apart? What are factors of 18 here that might be helpful? 9 times 2. Okay. Someone could also throw out 3 times 6, but which one do I want to use? 9 times 2, because I can take the square root of 9. I can't take the square root of 3 or 6, but I can take the square root of 9. So 18, I'm going to throw out 9 times 2. What is the square root of -1 again, class? I. When you walk in tomorrow, I expect you to know that, right? What's the square root of 9? 3. What's the square root of 2? Square root of 2. So what is I times 3 times square root of 2? 3i square root of 2. Okay. It's not that you're going to see, if I recall, there's not any on homework where it's just simplify them. Okay, I kind of wish it was on there, but I didn't see any like that are just simplified. However, are there going to be some other problems that you have to simplify within? Yes, and so that's why I need to get our brains flowing about, okay, how do we simplify these radicals when there's a negative underneath? Questions on this section? Okay, let's try the next section. I think you'll like the next section. Adding and subtracting. We're going to add and subtract with i's today. We're going to multiply, we're going to divide, and we're going to solve some basic equations. Find each sum or difference. So that means these are either adding problems or subtracting problems. Now, I said when we work with i's, I is not technically a variable in this situation. It's the imaginary unit. However, we're going to treat them like variables. The same rules that apply for adding and subtracting variables apply for adding and subtracting the I terms. So, thoughts on A. 4 minus 7i plus -11 plus 9i. Thoughts on what we do here? What kind of problem is this? What sign's in the middle? That didn't work. Addition, yes? So as we look at these, do the parentheses have any real purpose here? Not really. It's just saying that we're adding this complex number with another complex number. Where did I never really defined complex number on here, did I? Gosh darn it. That's a big oversight. Okay. These complex numbers, and what I should put, let me go back to the top here. Oversight on my part. These complex numbers, as we deal with them, you'll often hear us refer to them being in the form A plus BI. Okay, I meant to get that on there and forgot. But complex numbers that are in the form a plus bi, realize a is the real part and b is the imaginary part. Okay, so complex numbers that we're talking about are often in the form a plus bi. When you're asked in homework to write something in the form of a complex number, they're asking you for a plus bi. A represents the real part, bi represents the imaginary part. Okay? Now, the addition sign doesn't really mean anything, guys. We can, the addition sign does. The parentheses don't really mean anything. We can drop this off and think of it as 4 minus 7i plus negative 11 plus 9i. And if we look at that without the parentheses, because it's just saying we're going to add this complex number and this other complex number, what can we add here? Like terms, yes? I said it's just like if we had variables, yes? 4 is going to go with what? The negative 11. And 4 plus negative 11 is going to be negative 7. And then what else do we have in the way of like terms? Negative 7i goes with 9i. This is me just trying to pair them up for you. I'm not saying you have to rewrite it like this. What is negative 7i plus 9i? 2i. What is negative 7 plus 2i? Negative 7 plus 2i is negative 7 plus 2i. Okay? They're not like terms. We can't add them. We leave them in that complex number form of a plus bi. Okay? Did you have to necessarily show all that work for that problem? Not at all. We're just trying to put like terms together. Okay. Example B. What are we doing on example B? We're subtracting. Does that matter? Yeah. The parentheses have a little bit more of a purpose now. It's saying we're subtracting these two pieces. So, in terms of the real pieces, what am I going to do with the real pieces? 6 goes with what? 2, and we're going to have to do 6 minus 2, and 6 minus 2 is going to be 4. What about our imaginary pieces? There's an 8i. What's 8i go with? Okay, negative 5i, because it's minus 5i here, but then what else are we also doing? Subtracting. So we're going to have 8i and subtract negative 5i. What is 8i minus negative 5i? 13i. What type of 13i? Positive. So this is going to be 4 plus 13i. Not too bad, is it? I feel like I'm probably going too slow now that I think about it. But I want to make sure we don't miss any of the basics. Okay. Always stop and ask yourself, what kind of problem is this next problem? Addition, yes? Always check that sign out. Is it plus, is it minus, or is there nothing there? We'll talk about that option later. So, we're adding. What's negative 4 go with? So, negative 4 plus negative 2 is What is negative 4 plus negative 2?
-6.
Negative 6. Okay. Then what do we have in our imaginaries? 6i is going to be added to what? Negative 9i, yes? Realize when it says minus 9i, we take that as a negative. And 6i plus negative 9i is going to be negative 3i. 6 minus 9, negative 3. So negative 6 minus 3i. And D. What kind of problem is D? Subtraction. Did you catch it? Subtraction. Beware. So 3 goes with what? So it's going to be 3 minus negative 4. So 3 plus 4, which is 7. What about the negative 2i? Negative 2i minus I. What is negative 2i minus I? Minus 3i. Because what's invisible in front of this I here? It's a 1i, right? You're doing negative 2 minus 1, which is negative 3. Okay. Adding and subtracting isn't too bad, right? I mean, the hardest part there, watch out for the signs. It's going to be the ticky-tacky little mistakes that get us. The careless mistakes. So, okay, you can add and subtract. Let's multiply. Bottom of the page. Now, notice it says write each product in the form A plus BI. So you're writing your final answer in that A plus BI form. And I don't know. The Math Excel portion of Savvas could be kind of picky about how you enter that. Not 100% sure there, because as I said, I forgot to check that. But thoughts on how to multiply 3i times negative 5 plus 2i? How do we multiply? We're going to take 3i and what? Distribute. Okay. What is 3i times negative 5? Well, it's the same as asking what is 3x times negative 5. Just multiply and tag the variable along. So 3 times negative 5, negative 15i. And then what? It's plus. What's 3i times 2i? 3 times 2 is 6. What's I times I? I squared. Can I add negative 15i and 6i squared? If they were x's, could you add them? No, they're not like terms. They don't have the same variable pieces. It's an I and an I squared, or like an x and an x squared. Can I leave my answer like this? Write each product in the form A plus BI. Does it say anything about their A plus BI plus CI squared or anything like that? No. We can't have an I squared in our answer. Go back to the top of the page. What did we say about I squared? Yeah. I squared is equal to negative 1. So guess what? Every time you see an I squared, what are we going to sub it out for? Negative 1. So this 6 is 6, but I squared is negative 1. So instead of 6i squared, take the I squared, replace it with negative 1. 6 times negative 1 is negative 6. I still have the negative 15i. And my plus 6i squared just became minus 6. Basically, that I squared, take the I squared off, and it changes the sign of the number, doesn't it? Okay, that's kind of the, if you're a shortcut type person, that's what you're going to be doing. Officially, though, it's multiplying by negative 1. Now, are we done? Can I go any farther with negative 15i minus 6? I cannot. They're not like terms. Will the homework let you put your answer in like this? I'm not 100% sure. And it's being nitpicky, I know. You might be able to put your answer in like this, or what might you have to do? If we're going for a plus bi form, this is bi plus a, if you think about it. So if they want to get nitpicky, what do you need to put first? The a part, the real part. And so I need to flip what kind. I need to put my 6 out front, my 15i out back. It's what kind of 6? Negative 6. It's what type of 15i? Negative or minus 15i. So to be safe, I would put it in as negative 6 minus 15i. Now, in all honesty, it might let you go with negative 15i minus 6. But good habits means we put it the real part and then the imaginary part. Okay, that's common expectation there. Okay. So it's just basic algebra. It's just when you see those I squared, you have to go a step farther. B when you're ready. How do we multiply B? How do I multiply 4 plus 3i and negative 1 minus 2i? You're going to say it? FOIL. Okay. It's a binomial times a binomial. So I often say FOIL. If you don't like the word FOIL, it's also a big old distributive property, yes? So we're going to distribute the 4 first. First term in each parenthesis, what is 4 times negative 1? Negative 4. Then we distribute the 4 again, or we're doing the outside terms. 4 times negative 2i is going to be negative 8i. Now we have to distribute the 3i, or I'm doing the insides. 3i times negative 1 is negative 3i. And then I'm going to distribute the 3i one last time, or in other words, I'm doing last. 3i times negative 2i. Three times negative 2 is negative 6. I times I makes it I squared. Okay. Can't stop here. We have some cleanup work to do because, again, I'm trying to go for the form a plus bi. What pieces of cleanup do you see? I squared. Can I leave an I squared? No. What do we know about I squared? It's a negative 1. So if you're thinking about this as negative 6 times negative 1, that's really going to become what? A plus 6. So I'm going to, if I just copy the rest down, negative 4 minus 8i minus 3i, but instead of minus 6i squared, I'm going to have plus 6. Okay. What's the final step here? Putting together our like terms here. What's negative 4 go with? 6. Negative 4 plus 6 is 2. And then, what about our i's? What's negative 8i minus 3i? Minus 11i. And what is 2 minus 11i? our answer? Okay, good. Okay, they're not like terms. I can't go any farther with them. What about C? How do we multiply? It's 7i and 3i that we're supposed to be multiplying. How do we multiply those on part C? Just multiply them together? Is this a FOIL or distribute problem? No. There's no terms being added or subtracted. This is just what is 7i times 3i. 7 times 3 is 21. I times I makes it I squared. You're not going to leave it as I squared, though, are you? What is I squared? -1. So 21i squared is really 21 times -1, or in other words, -21. I'm fine with this. And I honestly think I did try something like that. I think you're okay with an answer like that. If you put an answer into the computer like this, and it says it does one of those things where it says your answer is correct, but not in the correct form. You know what I'm saying when they do that to you? Then it's -21 plus how many i's? 0i. Okay? So if you get caught in that situation where it's requiring it to be an A plus a BI, throw a 0i in there. As I said, I really think they'll be okay with -21, but as soon as I say that, you guys are going to come back complaining that it didn't let me put that answer in. Okay. One more in this lesson, or in this section. How do I multiply 3 minus 2i times 3 plus 2i? Okay, distribute or FOIL. I heard them both. Whichever makes your brain happier to think about. So, multiply with me. 3 times 3 is 9. 3 times 2i. 6i. Insides now, minus 2i times 3. Minus 6i. And minus 2i times positive 2i. Minus 4i squared. Okay. Well, what do you see? Okay. That minus 4i squared is really minus 4 times -1, which is a plus 4, isn't it? Excuse me. What else? If I go ahead and carry the rest down, 9 plus 6i minus 6i plus 4. What do we get?
13.
What is 6i minus 6i? 0. It cancels, doesn't it? Okay. So this answer would just be 13. Because those guys right there are going to cancel. And again, I'm fine with 13. If you have to get official, it's 13 plus 0i, isn't it? Okay. Now, that's probably about a good stopping point, but what I want to talk about, this is a situation where my i's canceled out, yes? I don't know, do you guys know the vocabulary for what something like 3 minus 2i and 3 plus 2i are? When they have the same terms, but that middle sign is different? Not the direction I'm going. Okay. When you guys have to rationalize with radicals and stuff, you use the word conjugate. Okay. So when you have the same pieces there, but the sign is opposite, they are conjugates. And the top of the back page, where we'll start tomorrow, talks about complex conjugates. Because the idea, they're complex numbers with equivalent real parts and opposite imaginary parts. The nice part is their product is a real number. The fact that I multiply these and my eyes drop out and I get a real number is important. And we will use that tomorrow when we are trying to simplify these fractions. Because we can't really divide complex numbers, but we can simplify them. And we'll use our conjugates to do that. So we have that. We have some basic equations to solve tomorrow. Okay? We'll pick up there.